Okay, now I think I see why they do some of the simplifications. So, again, correct me if I'm wrong. Here's our y-axis. Here is our x-axis. Here is it's our z, but it's really sort of our magnetic flux density. Okay, so you've got a power line again. Power line runs, say, like this. Take my orange pen. We think about, well, the magnetic flux density, at least in the simplest case, sort of looks like this. Kind of goes like that, and it sort of drops off, right? Sort of forms this curtain. Close enough. Curtains on the other side too. I'm not going to draw it. You get it. It's more like a tent. I guess it depends on the function itself. Okay, so then you take a power line. I see. So you take a power line here, or you take a pipeline. Say you've got a pipeline that goes at an angle again, like this. Right, and so, what I'm talking about earlier is I'm talking about getting the surface integral, right? You can do this kind of surface integral. I guess it's kind of like up a little bit like that. But you don't need to do the surface integral. Well, surface integral certainly, I think, is the more accurate way to do it, but technically you don't need it, right? Because what you can then say is you can say, well, what's the value at this nearest point here? So you can say, this is what people are talking about. What's the highest voltage point? It's going to be right here, right? So you take this point called vmax, right? So you say, well, what's the measurement here? And so we can compute our B field here, right? Mu 0 I times 2 pi r. We know r, right? R is the distance, essentially. R will give you the value. R is the distance between here and here, right? So, we can compute that at this one point. So far so good, right? And, we can compute this, whatever, just call this like B, I don't know, call this point 0, B0. Right, and then we can also compute the lowest point here too. We can say like B min. Right, so we'll call this like B min. I don't know, B min, maybe B, I don't know what to call it. Same thing, right, mu 0 I, 2 pi r. But no, R is much higher here, right? So R is considerably further away. So our value here is going to be lower. What we could do instead is just say, well, we know this one point here. We know B0. We know the length of this line. We know L, right? So we multiply by L. And then what we can do is we can also adjust for the angle, right? So like this is going to be at an angle that's different, right? So we can adjust by some theta, cosine theta, which will give us something like if it's 90, it's going to be 1, and if it's not 90, it's going to adjust it downward. So we can also use this as an approximation for like the, well, this is going to give us the B field, but then we can do the math to get the B.